Benzil Benzillic acid rearrangement. Benzil Benzillic acid rearrangement type reaction. In this reaction, 1,2-diketone type molecules in presence of base will undergo rearrangement to form alpha hydroxycarboxylic acid type compound. Let us discuss one example: pH C double bond O and pH, that is benzil. In presence of OH minus, there will be rearrangement to form alpha hydroxycarboxylic acid derivatives type compound OH and one COOH. So alpha hydroxy carboxylic acid. Let us discuss the mechanism part. So when I take diketone PHC double bond O pH and react this in presence of base, we know that oxygen is electronegative, so carbonyl carbon will be electropositive. OH minus will make a nucleophilic attack onto the carbonyl carbon, and there will be generation of oxy anion. So in the first step, there will be formation of oxy anion CO minus OH and pH. Let us say this is oxy anion 1. Now what will happen again? There will be reversal of charge. So this will form C double bond O. Valency of carbon atom will increase. There will be migration of phenyl ring and generation of negative charge on the oxygen onto the adjacent carbon atom. So there will be a rearrangement. pH will migrate O minus onto the adjacent carbon atom. Here there will be C double bond O and OH. Again there is a negatively charged oxygen atom. Let us say this is oxy anion 2. Now what happens? This oxy anion will try to form a more stable oxy anion. So this O minus will attract the hydrogen atom. From OH, or we can say hydrogen atom of acid groups, and there will be generation of negatively charged oxygen atom, that is C double bond O minus, that is carboxylate ion pH. This one as it is. Here after attraction of hydrogen there will be formation of OH group, C double bond O and O minus, that is there will be formation of carboxylate anion, which is more stable, and so it will be the driving force of the reaction, that is migration of phenyl ring will take place. This O minus can be migrated on adjacent oxygen atom also. So this is a resonance stabilized oxygen anion, which is more stable. Carboxylate anion is more stable as compared to oxy anion. So this will be formed, which is the driving force of this reaction. Now last step will be protonation to form acid PH, OH and COOH, that is alpha hydroxy carboxylic acid derivative, alpha hydroxycarboxylic acid compound. So in benzil benzilic acid, 1,2-diketone will rearrange to form alpha hydroxycarboxylic acid type compound. Now let us discuss another example. Suppose I have a molecule like aromatic. There is one cyclic ring, these two are aromatic ring, and two ketone groups. Now what happens in this reaction? Suppose first step, we already know OH minus will make a nucleophilic attack onto the carbonyl carbon, and there will be generation of oxy anion. So first step, there will be formation of oxy anion as shown here. So O minus and here there will be attack of OH. So now this charge will again try to revert back, that we have discussed in the earlier examples. Oxyanion will try to reverse back. In the earlier example there was a migration of phenyl ring. Now here there will be migration of carbon. So this C double bond O will revert, valency of this carbon atom will increase, so this bond will break, bond pair will migrate to the adjacent ring, that is carbon of phenyl ring, which will make a nucleophilic attack onto the adjacent carbonyl carbon, and there will be generation of oxyanion. So here there is a ring contraction type reaction, that is 6 member is converted into 5 member. Let us say this number is 1, 2, 3, 4, 5. This bond is broken, so there is a joining between 1 and 5, so we can say that now 6 member ring is converted into 5 member ring. So let us rewrite the structure, and these two aromatic ring will be, I will be writing as it is. Now 6 membered ring is converted into 5 membered ring, so I am rewriting as a 5 membered ring. So now let us discuss the numbering part. In the above we can say fifth carbon. Here fifth carbon there is a presence of O minus, and there is a presence of COOH group, so I can rewrite here as O minus, and there is a presence of C double bond OH group. So numbering will be a easy part to represent the group which is present on the fifth carbon atom. Now in the earlier example we have discussed that carboxylate anion is more stable than oxyanion. So again this oxyanion will make a attack, it will attack hydrogen atom, and there will be generation of carboxylate anion. So there will be generation of carboxylate anion from oxyanion. So I can rewrite this structure as 5 membered ring. Here there is a OH and C double bond O minus. So this can be resonance stabilized with the another oxygen as discussed earlier. Last step will be protonation to form alpha hydroxy carboxylic acid type compound. Alpha hydroxy carboxylic acid type compound OH and COOH. Now let us discuss one more example. Suppose I have only one 6-membered ring with the presence of two carbonyl groups. See, earlier example we discussed that there was a ring contraction, there is a formation of 5-membered ring from 6-membered ring. So here also it is a similar type of molecule and similar things will be observed. So OH minus, it will make a nucleophilic attack onto the carbonyl carbon. There will be generation of oxyanion. There will be generation of oxyanion. So here OH, O minus, and C double bond O. So this is oxyanion 1 discussed in example 1, oxyanion 1. Again there will be reversal of charge, so valency of this carbon atom will increase, this bond will break, charge will shift to the adjacent carbon atom, so this will be electron rich, and this electron rich carbon atom will make a attack onto the adjacent carbonyl group, and there will be generation of negatively charged oxygen atom. So if I rewrite numbering 1, 2, 3, 4, 5, so 5-membered ring is formed, this bond is broken, so there is a formation of 5-membered ring. So I am rewriting this as a 5-membered ring structure first of all. Now on the carbon number fifth, suppose this is a carbon number fifth, then in that carbon there is a presence of one O minus group and acid group COOH. So I am rewriting this hydrogen atom separately, COOH. So this is oxyanion 2. Now this oxyanion 2, what will it do? It will try to attract the hydrogen atom of carboxyl group as it is labile, and charge will migrate to the oxygen atom of carboxyl group, as it is a resonance stabilized ion. So there will be formation of carboxylate anion. Here there will be OH and C double bond O minus carboxylate anion. This carboxylate anion is resonance stabilized. It is more stable. And the last step will be protonation step. Last step will be protonation step. There will be formation of alpha hydroxy carboxylic acid derivative.